12.4 cross product part 1. We'll have multiple videos with this section, breaking it up into small pieces. Well, first of all, if we have two vectors, u and v, you can pretend those are in a horizontal plane, u closer to u, v farther away. The cross product, first of all, is perpendicular to that plane. So if this were in the xy plane, this would definitely be in the k direction. And you can use your right hand to go from u to v, your thumb points upward. So you have to know whether to go up or down. If you were to reverse this, if it was v cross u, your thumb would point downward and the vector would be going in the downward direction. Now, you can specify direction with this n as a unit normal vector. It's a vector of length 1. That's mutually perpendicular to both u and v. And we put that on the end. And then the direction of the vector, it turns out, is just magnitude u, magnitude of v, sine theta. That defines how long it is. For a given two vectors, or two magnitudes, it's going to be maximum length when sine theta is 1 or theta is 90 degrees. So, and when that's true, when u is perpendicular to v, sine theta is 90, then you can just go ahead. The magnitude of the cross product is the product of the magnitudes. When u and v are parallel, sine is 0 with 0, the whole thing is 0, so we get a 0 cross product when they're parallel. U cross the 0 vector is the 0 vector, quite simply put. You can put a 0 vector in here, it zeroes everything out. And also, u cross v is equal to negative v cross u. It doesn't commute. The cross product is not commutative. You can reverse it, but you have to introduce a negative. And you can see that with the geometry of it. And in the next video, when we talk about a determinant definition of a cross product, you'll see how that plays out as well. So we're going to start with some simple vectors, I, j, and k. I is parallel to x, j, y, and k, z. And we're going to very quickly apply this definition. I cross j. Of course, if your fingers go from I to j, it goes in the k direction. And this unit normal vector here would be k. Magnitude of I is 1, magnitude of j is 1, sine of 90 is 1. So we have a whole lot of 1s, and we just get k. Very easy to remember. J cross k, fingers go from j to k, your thumb goes in the I direction. So we get that, plus a bunch of 1s multiplied. K cross I, fingers go from k to I, your thumb points in the j direction. Okay. Now if you reverse this, j cross I, negative k, k cross j, negative I cross k, negative j. Of course, there has to be an easy way to remember this, whether or not we introduce a negative or not. And it turns out there is. First of all, if you're crossing two different letters, the third letter gives you the answer, and the only question is whether or not it's negative. So very simple. We can make a very simple diagram. I, j, k, and we just go forward alphabetically and then back to the beginning. Now, when you're doing a cross product, if you're going with the arrow, it's positive. Against the arrow, it's negative. And you can even add constants to this. So, for instance, 10j cross 15i. Okay, you can see the 10 and the 15 are going to carry through right here and here. 10 and a 15 times whatever that normal is. So that's going to be 150 j cross I. Let's see, we're going against the arrow. And so the answer is negative k. Of course, you can simplify that to negative 150k. Okay, which is a lot of money, but that's a different k. So for instance, if we have 20i cross 10k, okay, 20 times 10, 200, I cross k. Okay, again, we're going against the arrow, so it's going to be negative j. Okay, and so you get negative 200j. Now you can actually prove that the cross product is distributed. Not easy to do. It can be done with this definition, but it's not easy. There's a math definition that's much easier to prove the distributive property of the cross product, but we'll just assume it here. So for instance, let's suppose we had 2i cross 3i plus 10j plus 2k. Well, we get 2i cross 3i plus 2i cross 10j plus 2i cross 2k. Well, I cross I is parallel to I. 2i is parallel to 3i, so what did we say? Get the zero vector, so we can just forget about that. I cross j is k, so we get 20k. Okay, and I cross k, we're going backwards, we get negative 4j. Okay, and you can write this alphabetically, negative 4j plus 20k. Now, if you want to check, I told you this answer is mutually perpendicular. How do you check to see if it's perpendicular? Well, we're going to take a dot product. Let's just do a quick check. Negative 4j plus 20k dotted on. Let's take this first one, 2i. Okay, that's clearly 0. And you also can do negative 4j plus 20k dotted on this bigger vector here, 3i plus 10j plus 2k. And guess what? Negative 4 times 3, negative 12. And 0 times 10. Okay, negative. Sorry about that. I made a mistake. Okay, we have 0 times 3. There's no I component here. Negative 4 times 10. And then plus 20 times 2. And we get 0, and that checks. It's a good check. It's good to do these things over and over again. It reinforces the basic geometry of dot product and cross product. So, okay, that's all for part 1. We'll be back with part 2 shortly.